Good morning, everyone. Today we are going to explain how to use the LLX for simulating the low-level output using our CMC 430 and the LLX3 accessory unit and the Omicron Test Universe software. So in the beginning, let me explain what's available in the user manual of the LLX as you can see in our screen. So going to the LLX3, here is the designated use for the LLX3 to generate the low-level signals which be isolated from the CMC 430, and it will be connected to the device under test such as the protection relay to simulate such kind of low-level input for voltage and current sensors using the CMC 430. And here is the back panel and the front panel view, and the connection or the wiring of the LLX3 as explained in our brochure and user manual of the LLX. Here you can connect the CMC 430 to the LLX3 using the expansion port. Then you can use the standard test cable with the adapters to be used to be connected with the device under test to simulate low-level voltage and current values. And as you can see, here is the recommended terminal adapters and recommended wiring to be used in such connection. Then if you can see, here is the steps how to connect the LLX3 step by step. So for step 1, you can connect the adapter to the device under test. Then you can connect the standard test cable to the adapter. Then in step 3, you should connect the standard test cable to the LLX3, and using an expansion board, you can connect the CMC 430 to the LLX3 back panel. Then you can connect the CMC 430 to power supply and switch it on. Then you can start your simulation. So in the beginning, we will open a new test document from the test universe as shown in our screen, or you can open directly the quick CMC. Then it will appear like this. So first you have to double click the hardware configuration and choose the test set, which is a CMC 430 in our case. And then you have to disable the voltage and current values. As you can see, only enable the extension and the expansion ports to be used with the LLX3, and then select in the amplifier and the sensor simulation, select the voltage sensor. Then you can configure the ratio between the display value and the output value to be 1 volt over 1 volt. Then you can click OK. After that, you can open the quick CMC. After you open the quick CMC, you can select the frequency to be DC in our case, and you can simulate for the voltage L1 to E phase from 1 millivolt to 10 millivolt, and we will check the accuracy using the Enerlyzer. Then we can open the Enerlyzer from here also. It will be open like that. So in this tab, you have to choose the test set to be connected with the CMC 430, which is already online, as you can see. Then you have to simulate, and you can select the type of voltage to be a single phase, and the VT ratio to be 1 volt over 1 volt. Okay. Then you can connect the binary input 5 of the CMC 430 to be used for checking and for measurement of the low-level voltage values. You can configure the range from here. So for example, if you need values less than 10 millivolt, you can check this range, or if you need more than 10 millivolt up to 100 millivolt, you can use this range. Then in the signal values, you can add the EC values from here to be used, or DC values from here also to be used for measurement, and the frequency and the DC values, as you can see here, so all already added and available for our measurement. And you have to make sure that the CMC 430 is connected and it's online from the green button here, which means the measurement is online. Then we can open the quick CMC. We can inject like 1 millivolt in the beginning. As you can see here, the voltage value now it's 0.94 millivolt, which means there is 0.06 millivolt error, and this is in our accepted limits, as we can see from the manual, from the LLX user manual in the technical specification here. Here is the accuracy level if we are using a DC voltage, and you can see here is the amplitude accuracy from 0.8 volt up to 1.6 volt, which is 0.08 percentage from the set value plus 0.03 percentage from the range. So we can inject more than 1 millivolt, like 5 millivolt, for example. And you can see here the DC voltage in the right screen, which is 4.91 millivolt. We can increase to 10 millivolt. So it's 9.94 millivolt. And if you are increasing the value, I think you will find more and better accuracy. Like if we injected 10 millivolt, 20 millivolt, it will be 19.94 millivolt. So we can inject more than that, like 50 millivolt. Yeah, it's 49.94 millivolt, which means 0.06 millivolt error. This means 60 microvolt. And in that range, we have more than that in our accuracy limits. So it's accepted based on our technical specification for that range. Furthermore, if you need to adjust the accuracy to be more accurate, we have another parameter I will show you now from the hardware configuration. Here is a hardware configuration, and we have one more correction factors can be used to adjust and to increase the accuracy of the amplifier and the voltage sensor. So as you can see here, we have a correction factors. So we can use the amplitude factor for phase 1 to be 1 or 0.9 or 1.1 based on what do you need to adjust. And if you look to the help button, you can see here the amplitude factor for phase 1 and 2 and 3 can be 1 or 0.9 or 1.1. I mean, for the ideal case, it will be 1, but if you need more adjustment and more accuracy level, it can be adjusted here, and it will not display it, and it will be noted. It will be not noted anywhere in the software, and the value will be multiplied by this factor. As you can see, the output signal are multiplied by this factor. So, for example, I can put it only 5 microvolt, so 1.005. Then I will press OK. We can open the quick CMC again to see the effect of the correction factor. So I will inject, like I will start with 10 millivolt. Here is the 10 millivolt. Now it's 9.97. Now before using the correction factors, it was 9.94. Okay, so now the accuracy is increased based on this correction factor to increase the accuracy level and the sensitivity of this low level signals. Okay, so we can use another values like 5. Here is 5 millivolt. Now it's 4.95. We can make it 20. Now it's 20.06 millivolt, which was 19.96 before using the correction factor. Okay, so this is the explanation how to use the LLX3 with the CMC 430 for such low-level voltage signals, and using the Enerlyzer also to check this kind of low-level signals. Now we can stop the injection. And here is the accuracy level as we explained, yeah. So I need to give you one more tips and tricks for the test object. If you find any issue in the accuracy level or the low level signals, just make sure to adjust the device here to low value. So now the V maximum is 1 volt. So if you are using this V maximum to be 100 volt, for example, the accuracy will be affected. So once you need to inject from 0 to 100 millivolt, so there is no need for high value of the maximum voltage to be injected. So you can adjust the limit of the Vmax to be 1 volt. Also, you can adjust the V nominal and the V nominal primary and secondary to be 1 over 1 in case of line to line, and it will be 577 millivolt line to neutral between primary and secondary to just increase the accuracy level of this voltage values. We can do the same also for the I nominal to be 1 over 1 in case if you need from 0 to 20 milliamp or from 4 to 20 milliamp. So by the same way, you can use also the CMLab for the other CMCs like the CMC 356 as an accessory for the low level outputs. And we have a wide range, as you can see, for the LLX accessories. We have LLX1, LLX2, LLX3, and also it can be used for the device under test, such as a protection device, or can be used also for the reclosure. And here is a wiring example. Okay, thank you. And if you need any more details, just feel free to reach out. Assalamu alaikum.